Hey yo, what is up guys, Akash here back with another video. Today we are going to interface the E32 LoRa module that we saw in our previous video with an ESP32. A lot of you guys asked for this. I also planned this project. So this is the E32 LoRa module which we used and saw in our previous video. Check that video out. I strongly recommend you do before watching this video. We'll connect this to an ESP32 module from DF Robot. So this is an inverted board which we'll take a look at later. It's connected to an OLED display as well. So we have this white board that we have designed and got manufactured, and we are going to use this and see how can we interface an E32 with an ESP32, or you can use an ESP8266, an Arduino, or anything else, because this ESP32 is coded with an Arduino IDE. So we made this breakout board in our last video. I've connected this module to a phone using a serial monitor. So this is the serial monitor, and this is standalone. So what we are doing today is whatever message the LoRa module receives, it will send it to the ESP32 module, and this ESP32 module will show it on the display. So suppose I say hi over here and send it, you see these messages going, and then it says hi over here, and we see an acknowledge message which this module sends using LoRa over here to this module, and this module shows it over here. So I'll send another message, say CETech, and observe the LEDs. So the second time the LEDs blink is sending the acknowledge message, and we see CETech over here. So this is what we are going to make today. If you're interested in this project in interfacing the E32 module with an ESP32, or you can use this same method, code and diagram for ESP8266 or even the Arduino as well. If you're interested in this, stay tuned to the video. I order all my PCBs from JLCPCB.com. They offer 10 PCBs for $2 only. They also offer quick turnaround time and can produce PCBs as fast as within 24 hours. To design PCBs, you can head over to EasyEDA and then generate Gerber files for your project. Now head over to JLCPCB.com, upload your Gerber files, and get the PCBs manufactured for cheap. They are currently also offering discounts on shipping. So for our project, the main part is the E32 module from eByte. So this is the 100 milliwatt version of the module, and this is the 1 watt version of the module. They are operated in a similar fashion. We also need an antenna to connect to the modules. Without the antenna, you have the chance of burning these modules away. So in the last video, which I'll link down in the description below, we created this breakout board which breaks out the serial port of the E32 module, so the module can fit like this. But we didn't interface it to any ESP32 or any microcontroller, which we will do today. So for that, we have the ESP32 Fire Beetle board from DF Robot that we are going to use. We'll upload an Arduino code onto this, which will be in my GitHub repository, which I'll link in the description below as well. And we need an OLED display. So this is an I2C 0.96 inch OLED display which will display all the information. As we saw in the last video, we used this circuit, so I'll not draw this circuit again. We assume that this is in this board, which will be in our new PCB as well. So I'll directly use the RX and the TX ports. Let's take a look at the circuit now. So the central part of our project is the ESP32, which I'll show by this black box. This is the ESP32. And apart from that, as I said before, we'll use this as a complete block diagram. So this we have as this board, which you can assume that is the E32 breakout board with the entire circuit in it, with the mode switches, the resistors, the LEDs, the transistors, everything. So we say that this is the E32 breakout board. All right. And we have the OLED display as well. There we have the OLED display, and we need to see the connections between these three parts majorly. The ESP32 is connected to the E32 breakout board using a UART communication. So we have two lines, and this is TX and this is RX. And apart from that, we have ground on OLED as well. So we have ground over here We have VCC also over here, so we have VCC over here and over here as well. So all the three modules are connected to the power obviously, and the TX pin of the E32 breakout board will go to the GPIO 16 to the ESP32, and IO 17 of ESP32 module, that is this DF robot fire beetle module, will go to the RX pin of the E32. On the OLED side, the SDA pin, that is the I2C, and SCL pin will go to the SDA pin and the SCL pin of the ESP32. So on the ESP32 we have SDA and SCL, which is IO21 and IO22, which we have over here. So you can take a closer look. We have the SDA and the SCL pin, which we are using to connect to the OLED display. So I put this entire circuit, including this over here, on easy EDA and designed a PCB, and then I got it manufactured from JLCPCB. And there we have our PCBs. These are the PCBs which I got from JLCPCB. It says LoRa open source LoRa E32 ESP32 OLED dev board. So there we have it. This will go somewhere over here. So as it says ESP32 flip. So as we needed to see the pin numbers which are on the back, I did it back upside down. It'll go over here, it'll go over here, and this board will go somewhere over here. So I got into soldering. I soldered this entire board with my components, and this is the result that we got after soldering the board. So it's all ready to work. We also have a reset button over here, because when flipping this upside down, the reset button gets hit, so we have it over there. And there's this marking of this square over here. So firstly, let's put in the ESP32 on the dev board. There we have it. Then we put the OLED screen over here, and then we finally put our LoRa module, aligning it over here. And there we have it. Our board is entirely ready. And now I've already flashed in the ESP32 board with the code that we have, and I'll put that code in my GitHub repository, links of which will be in the description below. You should upload that code first and then power this project up. So I've uploaded that code, and now we can directly connect it to USB power. So that's what I'm going to do right now. And as soon as I connect it to power, we see E32 test written on it. So that's what I've programmed my board to do. So now what we have on the other hand is our old school friend, the E32 breakout board from our previous video. Connected it using an FTDI board to this end, which will go to my smartphone. My smartphone has a serial terminal app which we'll use to send messages and see what messages have been received. As this is all ready, I'll just connect to the serial port of this module, and I'll try to send some message. Say hello. And sending this message, we see the LEDs blinking, and hello is also written over here. So it's confirmed that we found the message over here. And on the phone as well, we see that we get an acknowledgement message. So let's try something else. Say 1 2 3 4 5 6. So it's 6 no problems. We have sent that message, and we see that appears on the display, and we get an acknowledgement message as well on this. So that is how it works. What you can do now is you can take the code that I've put onto this ESP32, and you can play with that code. You can control some LEDs. So what I've done is I've given a breakout over here of some GPIO pins and power lines. You can download the Gerber files for this project, which will be in the GitHub repository as well. You can get it manufactured, make some fancy project of your own, and interface this E32 module with an ESP32 without any problems using the circuit diagram of this. All the relevant links of the paths, the files, the diagrams will be in the description below. So do check them out and show some love to those pages and links and products. And that's it from my side for this video. Thanks for watching. Subscribe to our channel if you haven't till now. Also hit the bell icon to stay notified. This is Akash signing off.